All right, welcome in everybody. It's Mr. Lasitis here. Hopefully, you're having a good week without us, and hopefully, this Nearpod helps you with representing and interpreting data, which are the lessons you've got this week. We're proud of you for how you did on your TCAP test. We know that's a challenging time, but we got through it. So, we're looking forward to seeing you next week when we get back in person. All right, let's look at a few questions and a quick lesson on what representing and interpreting data is all about. So we'll start with some definitions. And the first one we're going to talk about is data. So the definition of data, it's a group of facts or statistics. So sometimes we'll see maybe it'd be like ages of students in the classroom or how many kids are in first grade, second grade, third grade, fourth grade. And we like to look at data to compare and find relationships between things. One of the ways that we can find those relationships is by plotting things on what's called a line plot, which is what you've seen in your lessons if you've already started those. And it's basically a graph that shows data as points. So let's pretend that we were doing ages of students in the classroom. Well, we'd probably the youngest age would likely be 9 at the very least, and maybe the oldest would be 12. So we could have our line plot like this, and in between we would have age 10 and age 11. And we would poll everybody in the classroom, ask how old they were. And most common is probably 11. So we'd have quite a few dots here for 11, and maybe a couple for 10, and maybe a few for 12, and maybe none for 9. So we wouldn't put any on there. And so we can use this to look at a nice visual way to say, okay, what's the most common age in our classroom? Well, in this case, we'd look at it and there'd be more dots on 11. So we would say that 11 is the most common. And that's just one of the ways we can use data and line plots. We'll head into some different scenarios here. Oops, I hit the wrong button. Hang on. All right. So this is a nice line plot that's represented for us here. And this model is representing hours spent reading. So it took a poll of what's the average hours you spend reading in a week. And so we can use this data to answer several different questions. A lot of times, these are the questions that will be in your lessons. For example, the most common question is probably something like this: what is the most common time? And in order for us to find what that most common time is, we're simply going to look in this case at the X's mark one student. And I'll look for the tallest line, is really what I'm looking for. And I can see that's this one right here. I can count them just to verify. 1, 2, 3, 4, 5. The next closest ones look like 1 and 3/4 hours, there's 4. And then in 3 hours, there's also 4 students. But 2.5 is definitely the most, that has 5. So I would say, what's the most common time spent reading? It's 2.5 hours. Another common question we would see: what's the difference between the most and least hours? So what's the spread of this line plot? So we would start with the most hours spent reading, which is 3, and the least amount is 1. And when you see that word difference, remember that's usually a subtraction. So we're looking for the difference between the most hours, which is 3, minus the least hours, which is 1, and that's 2. So the difference between the two is 2 hours, which is quite a bit of reading in between the first and last readers. And one of the last common questions is, what's the total amount of hours spent reading? This one's going to take a little bit more time because, as you can see, there's a lot of X's here, which means we have a lot of students reading. And so one way to do this would be to think, okay, on 1 hour, there are 3 students. So I could say 1 hour times 3, because there's 3 people doing 1 hour, equals 3, right? That's 3 hours for those 3 students per week. Okay, I go to 1 1/4. That's my next one that has a plot there. And that's only one person, so I would do times 1. That's going to be 1 1/4. So I'll fill the rest of these out, and then we'll come back and put them all together. All right, so I went through and multiplied all those by how many times they uh, were reported. So in other words, for 1 3/4, we'll look at that one. I knew there was 4 students that did that, so I did 1 3/4 times 4, and I got 7. So now we got to line all these up and add them together. All right, so after I added them all up, I ended up with 55 hours was the total hours spent reading by this class. And one thing to remember when you're doing that, it's best sometimes to cross them out.